Alright, this is just a short video on how to draw Lewis structures for molecules. We start with this discussion of Lewis structures for atoms. And by that I mean we have some atom B and we're adding the valence electrons, let's say boron. We have to know how many dots to put around it. This is our starting point for discussion of Lewis structures for molecules. So remember, in determining the number of valence electrons for an atom, we have to walk to it. And it says from left to right, or sorry, 7 steps to the left, but we want to say chlorine is 7 steps to the right. So 1, 2, 3, 4, 5, 6, 7 steps, and chlorine is at that 7th step. So we say then we have 7 dots or valence electrons that we have to put around chlorine. So that's what we've done here, and we put those around such that we go around the chlorine, some sort of left or right, top, left, and bottom, and then we go around again and we put those electrons in so that we have a total of 7 valence electrons. We can do that for boron, for carbon, and for nitrogen by again just looking at how far to the right we go to get to that element. So boron, it's 1, 2, 3. That's how we got to that look of having 3 dots around it. For carbon, it would be 1, 2, 3, 4. And then for nitrogen, we go 1, 2, 3, 4, 5. Again, counting from the first column in the periodic table as 1 and then going to that element. So nitrogen would be 5. So 1, 2, 3, 4, 5. Alright, so we can do that for atoms, but now we need to know how to do it for compounds. So we're going to look at drawing Lewis structures for compounds. That is, things that have more than one atom, and these atoms are different. So we can do that for both compounds and molecules, things that bring together 2 atoms or more. Remember, when we're looking at the need, what atoms need to be stable, we think octet. We think for the second row and third row elements, they want to have 8 electrons around them. And remember, in covalent bonding, we do that through bonding. So the number of atoms needed is equal to the number of bonds needed. So for example, carbon has 4 electrons. That's what it has as numbers that it brings with it to bond, but it wants 1, 2, 3, 4 more. So it always bonds 4 times in a neutral structure. Nitrogen always bonds 3 times, oxygen 2, and then hydrogen and fluorine, for different reasons, have just 1 bond each that they make in neutral structures. Remember from class, we talked about first finding the number of valence electrons for our chemical formula. So for example, in class we looked at CH2O. Before we do any of these rules for building a structure, always find the total number of valence electrons. For this formaldehyde, we found that it was 12 electrons we had to put into the structure. But once we did that, then we went right to the middle. We found that and built the frame, and then we added in lone pairs as needed. And to determine the number of lone pairs, we take the valence electrons that you found that has the total number of valence electrons we need. We had to get 12 in, and what we did in class, if you remember, for CH2O, we put the carbon in the middle because they had the greatest need for bonding, everything around it. These 3 bonds would give us 6 electrons, and we put in the 6 here as dots to get us to that 12, and then we dropped down to make a double bond. But the number of lone pairs that we had to add was 12 minus 2 times the number of bonds, 12 minus 6, which that gave us those 6 dots. Again, I'll make them really big. Okay, so that's a review. We can do the same thing for CO2 as another quick problem. Who's in the middle? Well, let's maybe first figure out how many valence electrons do we have. Well, we know for carbon it's 4. For oxygen it's 6, but because there's 2 of them, we times that by 2, and we know that we need 16 E's to go in to whatever structure we build. 4 for carbon, again, was the number of valence electrons he brings to the bonding party. Oxygen, there are 2 of them, so we know we need to have 2 for the fact that there's 2 oxygens, and each has 6 valence electrons. So 16 electrons. But to start in the next step, we said, now move from finding valence electrons, number 1, to putting the middle together and the frame around it. We kind of combined 1 and 2 here. So we know that carbon has need of 4 bonds. So we can put carbon in the middle. Now right now I only have 1, 2 bonds. That's 4 electrons. So I need to add in 12 more electrons, because 16 minus 12, or 16 minus 4, is 12. I need 12 E's to go in. And for step 3, we said that we want to put those from the outside in. Make sure to use the equation below to know how many lone pairs are needed. You can use that if you want, or you can just say, I know that a number I have that I need to put in. I know the number that are already there. The difference is 12, and so I'm going to turn the angle of these oxygens so we can see them. It's sort of sitting on the side now, not up and down. So if I put in the dots, that's 2, 4, 6, 8, 10, 12. This is, after step 3 now, all electrons added in. But we're not done, because we see carbon in the middle is not satisfied. The octet rule is not met. He wants to have 8 electrons around him. He only has 2, 4 around him. So we drop down to make our final structure. Now I've done all this work already above, but I want you to see again the process we work through. Number 1, find the number of valence electrons. Number 2, put the frame and the middle together. Number 3, add in the valence electrons or lone pairs as needed. We needed 12, so we put 6 electrons on the left, 6 electrons on the right, because it's outside first. And then drop down, if needed, to satisfy the octet rule for carbon, and it did need it. So that's a good structure at the end of our 4 rules, and we have that kind of summarized up here a little bit. But don't forget these steps. Find the valence electrons. We kind of put 1 and 2 together in class, and then we had 3 and 4 that we discussed in class. Alright. Now I could stop there, but maybe just kind of review just the explanation of the rules. Why do we use these? Well, we know the number of valence electrons. We know that we have to find the total number of these, because we cannot go above that number. But how we build the structure really kind of comes in right here. We know the total valence electrons has to be set by the chemical formula, but we put the atom of greatest need in the middle because we said in class, if you need a lot of bonds because it has the greatest need, then of course it goes to the best in the middle. So that was important. In the frame, we know that each atom must be bonded at least once to be a part of the compound. Then 3 just naturally follows. There are some leftover electrons that have to go somewhere. We said that we started from the outside in, because of course the outside is going to have less electrons than the middle, because he's got bonds off of them. So we wanted to watch, I guess, that video on H2CO, and we did in class. And we dropped down lone pairs when we needed to, if we need to have a filled valence shell. The octet rule has to be met. So just to summarize again for H2CO, which we did in the video, we said there are 12 E's, electrons. And then we moved to step 2, the second number 2 step, and we said that we have a frame that looked like this. Then we moved to step 3, and we had to add in, since we have 12 electrons, there's only 6 here, we had to add 6 more. So we had, after step 3, something like this. And then after step 4, we knew that we had to drop a lone pair down. We can pick any one of these to make a double bond, because then the carbon would be satisfied. And then we are done. Alright, that's it. We're going to watch a different video in class that is more sort of expands on these basic rules so we can do other structures. Thanks. Bye-bye.